And those two concepts are, first concept, what are called abstract classes. And the second concept is called interfaces. And I thought in order to explore these concepts, we'll pick a real world example, which is this little Space Wars game that we've been working on for the past 3 or 4 weeks. And we'll try and apply these object-oriented programming principles to, to the design of our classes in Space Wars. So, I'll just give a quick definition for each one of these, right? You should probably write this down, or maybe when I'm writing the code, I'll put the definitions in. But just briefly, I'll say an abstract class. An abstract class is a class where the methods have no body, or let's see, some of the methods have no body. That's the first thing to say. Second of all, abstract classes can't be instantiated. Third thing about them, must be subclassed. And there's one other rule. If you have a subclass of an abstract class and you don't implement, and let's see, subclasses must put bodies to the methods with no body. Otherwise, they are also abstract, huh? Okay, so I'll just run through those points again. First of all, when you make a class an abstract class, you're allowed to put some methods on that abstract class that don't have any body. Alright, so you just write the method signature and put a semicolon afterwards. You don't put open curly brackets, put in some code and close curly brackets. That's the first thing about abstract classes. Second thing about abstract classes is because some of the methods don't have bodies on them, you can't instantiate an abstract class. Well, you think you can't instantiate an abstract class, what's the point of an abstract class? The point of an abstract class is that it serves as the superclass for subclasses. If you want to say, and I'll show you exactly where we'll apply this in our Space Wars game. So when you make a subclass of an abstract class, you have to put the method bodies in for those methods that don't have a body in the superclass. And I'll say that again, you have to put the method body in for the classes that don't have a body in the superclass, in the abstract class. Otherwise, the subclass is also an abstract class. That's the rules for abstract classes. Okay, let's look at how we can apply this to the Space Wars game that we've been making. Right, this is the solution to last week's lab. It has pretty much everything in it. I went through some of this in Friday's tutorial, right? But most importantly, we have this base class called game object over here, and pretty much everything in our scene or everything in our game extends the game object. I'm going to do a save as, so I don't overwrite this example. I'll be able to put it up on the. I have a complete solution to this, but I'll just do a save as anyway. Okay. So there we go. So there's my class game object, right? And if you look at game object, okay, let's look down at game object, right? We've got these constructors, we have some fields, position, forward, and so on. But I have these two little kind of orphan, if you like, these are like appendices, right? They're little methods that at this point don't do anything and don't really serve any purpose in the game object base class, right? See update and render? Okay, so when you think of this example here, it doesn't make sense to instantiate a game object directly. We're always going to instantiate subclasses of game object. We're always going to instantiate bullets, or ships, or stars, or power-ups, things like that in the game. But we're never going to instantiate a game object directly, because a game object by itself, it doesn't make sense. If you want to think of a real-world example, right, you can think of an animal, right? Something is not just an animal. Something is always a subclass of animal. It's always a cat, or a dog, or a sheep. With the example that we made, you could never really instantiate an animal by itself. Do you get what I'm talking about? So the same thing here. So this is a really good candidate to make an abstract class out of it, right? So let's make an abstract class out of it. And there's just one additional keyword in Java to make something an abstract class. So you go class game object. First thing we do is you put the word abstract. abstract class game object. Now we cannot instantiate a game object. We can't instantiate a game object directly. We can only instantiate subclasses of it. So if you have the code from last week and the solution to the lab, then do this with me, okay? And follow along. So now game object is abstract. We want to put two abstract methods on game object. So there's update. This has currently got nothing in it, right? So there's no point in having an update and a render method in game object. We only want to put update and render methods in the subclasses of game object. So let's do that. So this becomes abstract. This becomes abstract. And then you just get rid of that, put a semicolon there, put a semicolon there. And that's an abstract class. So the consequences of making this an abstract class are we can't instantiate game objects, must be subclassed. That's okay because we already have our subclasses. We've got bullets and game objects. Sorry, we've got bullets and we have ships and we have stars, which subclass the game object. And then subclasses must put bodies into the methods with no body, otherwise they are also abstract. So I'll just show you what I mean by that. It's a bit weird happening with the keyboard today. Where's the close curly bracket gone? Maybe I deleted it. Sorry, I must have deleted one close curly bracket there. Okay, so that's my abstract base class. Apart from that, there's no other changes need to be made, right? But I just want to show you what the consequences of making something an abstract class are. Today, in this lab, we're going to make some other subclasses of game object because what we want is to implement two power-ups, right? So let's implement a health power-up or a lives power-up, and let's implement an ammunition power-up so we can control the amount of ammunition that each of the ships have, right? So let's say over here, I wanted to make a power-up for, let's say, lives. So there's lives power-up, right? Okay, so now class lives powerup extends game object, and that's all we're going to do for now, just to illustrate this point, right? Before we've even gone to run our program, it says the type classes4.lives_powerup must implement the inherited abstract method classes4.gameObject.render. So it's immediately telling you got a compiler error here. Because we have extended an abstract class, this class is also abstract unless I go and implement those two methods. Is that clear to everybody? There's nothing more to abstract classes than that. Those simple rules, and this is a really concrete example of where you would use an abstract class in a real program. Is that okay with everybody? Does everybody understand abstract classes? Yeah. So it's just those few simple rules, and that's abstract classes. There's nothing much to them apart from that. Okay, so let's draw a line under abstract classes, right? We've done abstract classes. Next thing we want to talk about, which is kind of related to abstract classes, is this idea of interfaces. And maybe what I'll do is I'll show you the program that we're going to work on, just to show you what is going to happen. And we can use interfaces to solve this problem, right? So recent examples, let's open classes 5. So this is the program that uses interfaces and abstract classes. This is what we're going to make. And what I've done in this program here is every second a power-up spawns. And just to make it clear, I've given each ship ammunition and lives. So you can see ammunition for the blue ship there. I'll zoom in a little bit. So I have 10 ammunition and 7 lives. And then there's, every second there's a power-up spawning here, okay? So if my little ship hits one of the power-ups, if it hits the little hexagon power-ups, then my ammo goes up. And if I hit the little white squares, then my health goes up. So I can go around now and I can collect all of these things, okay? This is what we're going to make today. And like I say, we'll use interfaces to kind of solve this problem a little bit. Okay, that's what we're going to make today. All right. So, yeah. So I'm wondering how should we be doing this? Let's jump over to the sketch that we're working on here. Okay, let's do the simple things first. Let's not even imagine. Let's not even put in the life power. Let's just put in the health and the ammunition, and get the ship to print the health and ammunition, because that's something that we should know how to do first of all. So health and ammunition, where should we put it? And how should I implement a counter for health and ammunition for each ship, what should we do? Give me some feedback here. What do you think we should do to implement health and ammunition? Where would it make sense to put health and ammunition into our program? Ship. And where should we put them? What should I make them? Fields. Thank you. Let's make them fields in the ship class. All right. Let's come over to ship and let's add 2 additional fields. So if you guys are following along, let's put in a field here for health. Oh, let's call it lives. And let's put in another int here for ammo. Okay, and let's make these, let's give them some default values here. Let's, in the ship constructor, let's say lives is equals to 10 and ammo is equals to 10. Okay, so we got 10 lives and 10 ammo. Now let's do a couple of other little things here. Let's, wow, I wonder should I put it into the default constructor or should I put it into this constructor? Let's put it into the parameterized constructor because it looks like the default constructor is using constructor chaining anyway. So this is the constructor that's actually going to get called. So let's put it into this constructor instead. Better. Okay, first step. Second step, in the update method for the ship, here we are, firing a bullet. So this is the solution to last week's lab, and we're going to fire a bullet if elapsed is greater than 12. So elapsed is just a counter that starts at 0, and then every frame I add 1 to it. Alright, so after 12 frames have elapsed, that's a fifth of a second, because I know I've got 60 frames a second. So that's how we solved the problem last week of being able to just fire 5 bullets per second. Alright, but the other thing we want to add a constraint here is I can only fire if the fire key is pressed, elapsed is greater than 12, and I have bullets. So if bullets is greater than 0. So if the bullets is greater than 0, what did I call it? Ammo, sorry, not bullets. If my ammo is greater than 0, if I press the fire key and the elapsed is greater than 12, then ammo is greater than 0. Last line of code here, of course, we need to basically decrement the ammo count whenever I fire a bullet. So let's go ammo minus minus. So that means that I have 10 ammo at the start because we initialize it in the constructor. I can only fire if my ammo is greater than 0, and then every time I fire ammo, I decrement the ammo count by 1 here. So when ammo reaches 0, I'll no longer be able to fire. Is that okay with everybody? Let's do the next thing. Next thing then, we want to just print out the ammo and the ammo and the health inside the render method here. So the render method here is using translate and rotate in order to implement this concept of encapsulation so that I can make this class autonomous and so that its rendering is not dependent on anything else. So let's add some printing. The right place to put it is between translate and rotate, okay? Because I don't want it to rotate with the player, I only want it to translate with the player. So, we'll just put in some text here. Ammo, colon, and then let's print the ammo amount. Now, we need to put it at a particular X and Y coordinates. Where should we do it? What X and Y coordinates should I use to print the ammo?
Position.x added with a few more.
Go for it, yeah. Position.x and Y.
Position.y, and then you just add a few.
Right. Anyone else any ideas? Yeah, that's a good idea. That's actually my first attempt. That's what I did, and then I realized that I'd made a little mistake, and that there's actually something else we need to consider. If you guys remember how we made this, look at how we're drawing the lines. We draw everything relative to the origin, because I use translate to bring it to the position in the screen. That's how translate and rotate works, you know. So translate and rotate will translate something from the origin to the position that it needs to be. And if you look at how we drew the lines here, you might remember this is about 3 weeks ago or 2 weeks ago when we did translate and rotate. We actually draw everything relative to 0, 0, and then we translate it to the position. That's what translate is doing. So that was my first attempt, and then I realized it didn't work, and then I fixed it and I made this one, right? So that's a good attempt, right? So there's the ammo. So I should probably print that over a little bit from 0. How about we print it at let's do W, because W is the width of the object anyway. So we can do it over W and down 0. And then let's print the, one thing I probably want to do is take the stroke up here, because I want it to draw in the same color as the game object. So I'll put the other one here as well. Text, there's ammo, and then health. Or lives, is what we call it. And then maybe let's print that at down 20. Okay, we can try that and see what it looks like. Let's try it out. But hopefully now, yay, there we go. There's ammo and lives printed out there beside each of the objects. And as you see, that translates to the position where the object is drawn to on the screen, but it doesn't rotate, you know. If I actually took that code and I put the rotate code above this, then we would translate and rotate. Oh yeah, the other thing is stroke C. How do we change the color of text that gets printed? Fill, exactly, yeah. So that should be stroke C, Control Z, Control Z. And then let's also do fill C as well. Cool, there we go. So you'll notice now that I'm translating and rotating the health, yeah? So the thing to do is to actually take the code and do the rotate after I've drawn the text, like that. There we go. Alrighty. Okay, so that's health and, so that's my ammo and lives stored as part of the ship. Let's just make sure that the decrementing thing works as well. So if you run your sketch now, there you go. See, ammo decreases by 1, and then eventually ammo becomes 0 and the ship stops being able to fire. Alrighty, do you want me to leave that up for a minute till everybody just catches up, or shall we move on? Okay, I just asked a question and nobody answered, so should I move on or leave it up for a minute?
Yeah.
Okay, I'll leave it up for a minute, okay? Yeah, so everyone get that much working and then we'll move on and do the interfaces thing, okay? Anyone need a hand with anything? Okay, if you're finished and this is all working for you, then why don't we move on and do the next bit, and I'll let you do this bit yourselves, okay? What we want to do is create another subclass of game object and call it ammo powerup. Or what did we do first of all? Lives powerup, okay? Okay, lives powerup. Let's make it also extend game object. So we'll use our inheritance here, okay? Let's make that extend game object. Let's just make it a very simple thing. Let's just make it draw a square, okay? A white square. That's what our ammo powerup is. Or sorry, our lives powerup. Let's say a couple of other things here about the lives powerup. Really what we wanted to do is something like this. But I'll let you see if you can figure out how to get it to do this, right? Look at how the lives get instantiated. Alright, so the lives do a cool thing, right? First of all, they're rotating. Second of all, they move in a random direction, and also when they go off the sides of the screen, they respawn over the other side of the screen, okay? So they respawn, and they also have a random direction. Okay, why don't I give you guys 15 minutes to see if you can figure out how to do that yourselves. Alright. An abstract class. This is is going to force us to put those two methods on lives power up, right? Because we made an abstract class out of game object, this class won't work anymore unless I put those methods on. If I didn't want to put those methods on, I could use this instead. I could say that lives power up is also an abstract class. And that just makes it an abstract class with the same rules here. At some point, if I ever want to instantiate one of these, I'm going to have to make those methods on something. You know, either a subclass of this or on this itself. So if I want to make a lives power up kind of a concrete class, then let's put those methods on. Let's put a constructor on first of all. Lives power up. Okay. So yeah, let's just make a default constructor for it. Okay. So first of all, well, let's give it a random position. So we'll give it a random position by means of constructor chaining. So if we look at game object, one of the constructors for game object takes the x, y, and w components, or takes the x, y, and w, fields. So for lives power up, let's just call super, and we'll pass in some random values. And let's make it a width, what did I do in my other solution? I made it width 50. Okay, so let's make it 50 width. So now, a couple of other things. Oh, sorry, the h value. That should be, of course, height. Okay, yeah, that's okay. I wonder, is there anything else we need? Probably, let's set the color of the lives power up, right? So C is the field. Let's make that equals to the color white. Okay. So now, let's put in the two abstract methods. Let's put in the render method first of all. So the render method is going to be all about just drawing the object. So we'll draw this object in the same way that we drew the other objects. We'll use push matrix, translate, rotate, and pop matrix, right? So push matrix stores the existing transformation. So this will store the existing translation and rotation. Translate translate to pos.x and y. We'll rotate. We rotate theta. Now we want to draw a box. So let's go rect. So yeah, let's just draw our rect. Alright, we're drawing our rectangle centered around 0, 0, right? So remember, the first two parameters for rect are actually the top left-hand corner of the rectangle. So instead of passing 0, 0 in here, because 0, 0 will mean that the center of the rectangle, if here's my power up, this is going to be the center of the rectangle, and I draw my rectangle like this. Much better would be to draw the rectangle so it's centered around the position. So we'll use minus half W. So half W is half the width, right? And then W comma W. There we go. So there's my rectangle. Oh, not forgetting to go stroke, C, fill, 0. We'll do the rectangle, and then we'll call pop matrix. Alright, so that's the rectangle drawn. That's the power up drawn. Okay, let's do the next thing, which is to add the update method here, right? So in our update method, we want to do two things. First of all, we want our object to spin. So the spin of the object is controlled by theta. So just do theta plus equals to 0.1f. And that will add 0.1 radians to the rotation of that object each frame. So every frame the object should rotate a little bit more, because we're adding a small amount to the theta value. Alright? The other thing we wanted it to do is to move in a random direction. This is the way I did the random direction thing, right? So from the game object, we have this additional p vector called forward. So why don't we use the forward vector? Let's take the lives power up, and we'll give the forward vector a random value. So forward.x equals random -1 and 1. And forward dot y is going to be equals to a random minus 1 comma 1. That's kind of enough. That's enough to get them moving in a random direction. If I wanted them to all move at a uniform speed, then I would have to do this, which simply takes that vector and makes it of length 1 to normalize it, right? So if it's a vector between minus 1 and plus 1, it might not be, in fact, it's very unlikely. Somehow you'll get something like 0.5 and 0.5, which will be a vector which is no longer of length 1. So if I use that to modify the position, that means some of these things are going to move faster than others. By normalizing them, you take the vector and you make its length equals to 1. So if I use that to update the object's position, all the objects will move at the same speed. Pos.x plus equals to, or you can just do pos plus, pos.add forward. That's a better way to do it. Then we're just using vectors, right? So I'm just going to add some vector to the object's position each frame, and I'm also going to do the theta thing. And then if I want my object to wrap around the screen, then we can just take this code here from the update method, which just which just checks the position to see does it go beyond the bounds of the screen, and then resets it to be back into the bounds of the screen. So that load of if statements here is going to implement the wraparound code, So there's lives power up. Let's put in update here, and we'll put in that code into lives power up. So there's my lives power up. Last thing we want to do is over here in game object, let's add one. In fact, why don't we just add one randomly every 5 seconds. In the background, in the draw code over here, every second. If frame count percentage 60, because frame count, don't forget, is a built-in variable in processing. 1 gets added to it every frame. So every 60 frames, 1 second has elapsed. So if we do frame count percentage 60 is equals to 0, then that means this is how we test, this is how we make something happen once every second. So we can go lives power up. In fact, let's use polymorphism here. Game object equals new lives power up. And then we need to go game objects dot add lives power up. Like that. That means every second we're going to add one to the screen. Let's see, does it work? There we go. They're getting added as red though, because I obviously did the colors wrong. Let's do the colors again. That color, oh yeah, it should be 255, 255, 255. And now every second we're getting a lives power up added to the screen. And they're all spinning, and yeah, they should hopefully get respawned once they go beyond the side of the screen. They'll get reset over to the previous side of the screen. Right, I'll leave that code up for a minute and give people a little while to take it down. If you've got this working, then take a break for a minute, okay? For 5 minutes or so. Okay, everybody, let's do the last thing. I'm really pleased to see everyone's figuring this stuff out. So let's do the last bit of this, which is the interfaces bit, okay? If everyone can look up for a second, let me just explain how we're going to solve this last part of the system, okay? So, what can we say about interfaces, right? First of all, okay, let's give the scenario first of all, right? So, the scenario is that we have this base class called game object, okay? And then I have a few subclasses of game object. First of all, we have the ship subclass. Then we have the bullet subclass. We then have the star subclass. Alright, so these arrows here indicate subclasses, yeah? And then to this we're going to add the power-up, right? So the power-up subclass that I have is a lives power-up, right? And lives power-up also extends game object like that, okay? So this is pretty much the setup that we have already. Now interfaces in Java allow us to do a few really important things. The first thing they allow us to do is to be able to say something like this, right? So I'm adding power up to this thing as well. And I'm going to not only have a lives power up, but we're going to also have we have lives power up, but we've got an ammo power up as well, right? And ammo power up also extends that as well. But they allow us to do this. Watch this thing here. So Java, by just the way it's designed, only supports what's called single inheritance. So you can't take lives power up and say that lives power up extends game object and also extends power up. You can't extend more than one class in Java. Some object-oriented programming languages like C++ allow you, and Python as well, allow you to extend more than one base class, but Java doesn't. You can only extend one base class. What you could do is, we could say that, could change this hierarchy around a little bit, and we could say that power up extends game object, and then lives power up extends power up. Alright, this is one solution to this, but then that means that every power up is also a game object. Do you see that? This is one way to solve this kind of multiple inheritance issue, you know. That just means lives power up is a power up is a game object. Okay? For the sake of today, let's assume that not all power-ups are game objects. Alright, for the sake of this example, let's assume that not all power-ups are game objects. So we'll go back to this thing that we want to do here, which is to make lives power-up extend game objects, but also be a power-up. So this is what interfaces allow us to do. They allow us to do this type of relationship. And this is the sort of scenario that we're trying to model now. Okay, so what to say about interfaces? I'll just put up a couple of notes then, right? First of all, interfaces are very similar to classes. Okay? But a few things about interfaces. Number one, interfaces, all the methods on the interface, or I should say none of the methods have any body. Okay? So interfaces. None of the methods have a body. Alright, because none of the methods have a body, a class can implement any number of interfaces. Unlike inheritance, where you can only extend one base class, you can implement any number of interfaces, right? And the key word here is implement. A class can implement any number of different interfaces. And then the last thing to say about interfaces, interfaces are used to implement a concept called design by contract. In other words, when you say a class implements an interface, you are guaranteeing that a class has certain methods on it. You're guaranteeing that the class has the methods from the interface on it, right? Guarantee that the class has the interface methods, right? And that's what we say about interfaces. Okay. Also, the syntax for interface is very slightly different than the syntax for classes. So let's make an interface here, right? So I'll show you how this works in practical terms. Let's make an interface called powerup.
Brian, what was the design by contrast?
So yeah, design by contract. When a class implements an interface, it's a guarantee that a class has certain methods on it. So that way, you can basically set up a contract between two classes. Okay. By that I mean, let's try to think of a simple example. It's almost like a protocol. You know, it's like a prior agreement between the two classes that they're going to be able to exchange information via certain methods. All right. So the methods. When a class implements an interface, you're guaranteeing that the class has those methods from the interface on it. So therefore, another class can call those methods safe in the knowledge that the class has got those methods on it. Right, that's what design by contract means, you know. Okay, So here we're going to make a contract. We're going to make a contract, and our contract is going to be called powerup. All right, I'll show you how this is going to work. Maybe when you see the practical example, it will help to explain it. So here we go. Here's our powerup. Okay. So first of all, I said interfaces are very similar to classes. The syntax is slightly different in that instead of writing class, you write interface. All right. So we say interface powerup. So what does every powerup need to do? Every powerup needs to do something to a ship. It's going to either modify the ship's ammunition or modify the ship's number of lives. So the way I've implemented this is I just put one method on it called apply to. Alright, so that's my powerup interface. That means when a ship finds a powerup, it doesn't matter what the powerup is. I know that it's going to have a method on it called apply to. You pass the ship in, it will do something to the ship. Alright, it will be different for each of the subclasses. So lives powerup, what will it do? It's going to add 1 to the ship's lives. Ammo powerup is going to add 1 to the ship's ammo. Alright, so we've got different implementations of the interface for each of the things that implements the interface. So we got apply to. So there's apply to. That's what the interface looks like. And like I say, it's got a list of methods on it with the signatures and then a semicolon. So now let's pick our lives powerup and implement the interface. So if we come over to lives powerup, the first one that we made, class lives powerup extends game objects. Next thing we put is implements powerup. Okay, so it extends game object, which means it has to put the methods on from the abstract class. And now that it implements powerup, we also have to put that apply to method on. So there's class lives powerup. And again, you're getting this error to say, look, the class must implement the inherited abstract methods apply to. So it's even giving you this warning that the class won't now even compile until we put the apply to method on it. And that's what an interface is used for. So let's put void apply to. Alright, and this means apply this powerup to this ship. So we go ship dot, this is the lives one, yeah? Ship dot lives plus plus. So this is now a contract, right? This powerup is a contract between the ship and any of the powerups in the game. That you're going to be able to call apply to on any one of these powerups, and it will apply the powerup to the ship. Is that okay with everybody? So that's how interfaces work, right? Now to finish this thing off, what of course we need to do is now we need to figure out when do we apply the powerup. And we're going to apply the powerup when the two objects collide. And when the two objects collide, we'll also remove the powerup from the scene so that the powerups disappear off the screen as soon as the ship collects them. Is everyone following along so far? Does anybody want to ask me any questions before we go on to the last little bit of this? Okay, we'll crack on with this last bit, right? So there's the apply to powerup on the lives powerup. Over here, I'm instantiating these lives powerup every second. At some point, I need to check to see that these two objects overlap, right? Now, we have a slightly tricky situation here. In that I just have my list of, let's see, what's the best way to do this? I'm trying to think of the most straightforward way to do this. Sure, we'll do it the long way. We'll do it the long way. But there's a long way and a short way of doing this. The long way is a bit easier to understand. The short way is better. Let's do it the right way. The right way. Okay. The right way to do this, because this is actually slightly tricky, because what we need to do is we need to basically see if the object is a ship and the thing that it's colliding with is a power-up, then we want to apply the power-up to the ship. Actually, we'll write it the simple way first. I think it's the easiest way, right? So what we need to do first of all is let's put check collisions. Okay, we'll do it the long-winded way, right? And the slightly longer way, and then we'll look at maybe improving. I do think this is maybe easier to understand. So void check collisions. This is going to check to see do we have a collision between a power-up and a ship, and if so, we'll apply the power-up to the ship, right? first of all, let's go through every game object. So we have this code up here to go through every game object. Let's take this code here again. And bring it down into the check collisions method here, right? So there's the game object. In fact, maybe this is, even though it's a longer way of doing it, it might actually, we'll hopefully learn something else as well in the process, right? If game object instance of ship okay, so this first bit here is just iterating through all of the game objects. I'll zoom out so you can see all of that code here. This method here is just going to go for game objects inside. So it starts at the last game object, goes down as far as 0, subtracts 1. So then I retrieve the game object from the array list, and I check to see if the game object is a ship. Do you remember we did this, or I might have mentioned this instance of? So instance of is an operator as opposed to a keyword or a method in Java, and it allows you to check the type of an object. So when you go instance of ship, this will return true if that particular game object is a ship. Alright, if it's a ship, then we need to go through all of the game objects and look for collisions between that game object and a power. So let's do another for loop in here, a nested for loop, and let's go J for this second for loop. J minus minus. So I'm going to go through every game object and compare it against every other game object, but only do the collision test for those game objects that are ships and power-ups. Okay? So let's go game object other equals game objects at position J. Game objects dot get. And then we could say if other instance of power up. So that means game object is an instance of ship, other is an instance of power up. We can check to see if they collide, right? So the easiest way to check to see if they collide is to check the distances between them. If you understand this code here, I'll just explain how the distance thing is going to work. Let's imagine that this is my ship, this is my power up, or maybe I'll draw them slightly differently. We know that they're going to overlap if the distance between the two center points of these objects is less than the sum of their two radii. Alright, this is called bounding circle collisions, right? Two objects overlap if their circles overlap. To check to see if their circles overlap, we get the distance between the two center points and check to see if it's less than the two radii. Does that make sense to everybody? That's called bounding circle collision, so it's very simple. Anyway, so if go dot pos dot dist other dot pos is less than go dot half w plus other dot half w, then I know that they've overlapped. Okay, and then we do the last thing, which is to apply the power up to the game object. So what we want to do now is, I know that other is an instance of power up, but in order to call the power up method on it, you have to cast it to be a power up. Okay, because currently its type is game object, so we can only call methods on the game object for other. You know, power up like this. Power up other dot apply to the game object. Now, okay. Casting all over the place here. Alright, that should work. And finally, let's just call game objects dot remove the power up. go other. There we go. So that will remove it from the list of game objects. Alright, that's how we do bounding circle collisions. That's probably the trickiest thing today, you know, doing that bounding circle collision test. Hopefully the interfaces are not too hard, but that's, you know, obviously it's a little bit of code to implement that. Let's see, does it work, right? Okay, so if it works, I should be able to hit into these things. Yeah, lives goes up, and they disappear. Awesome, it's working. Okay. What you think, everybody? That last bit is just a little bit complicated, but hopefully that's how you do collisions in games, you know? You have to check every object against every other object. Check the distances between them, or even do more complicated collisions if you want to check the actual pixels of one object against the pixels of another object. But for all the games I make in processing, this is how I do my collisions. I just check the bounding circles overlap, and it kind of works, you know? Most of my games, the collisions are okay. People don't notice that they're not exactly overlapping. This works really fine. Because the games are kind of fast anyway, they don't have to be exactly overlapping. Alright, so a couple of interesting things to note here. This is how you check to see if one object is a subclass, or if one object is another object. Or check the type of an object maybe, yeah? That's checking the type of an object. This is bounding circle. Bounding circle collisions, and then we have to do some casting. Okay, I'll leave the code up there for a minute. You guys can try it yourselves, and then once you have this working, why don't you try implementing some other power-ups? So try implementing the same code with the ammo power-up and get it to randomly spawn either ammo or lives power-ups. And then make sure that you can move around the scene and that you can pick up ammo or lives. And obviously make sure your ammo and lives implement the interface as well, okay?